Okay, hi guys. Back to this second part of my tutorial about asynchronous calls or coroutines in Python. So we'll be coding up something today. We might need to break this coding session into two videos depending on the time it takes. We'll try to finish it in this one, but let's see how things goes. Uh, so firstly, create a normal file, say async.py. Uh, we need to import our async IO library. We might need the time library as well. Okay. Uh, Now inside the main, we are calling some fetcher, let's say, or we can call it a driver function as well. URLs. Okay. So it's just like the scenario we tried to make in the previous video. We have multiple websites. Okay. Uh, and we have their URLs. Okay. Here I'm not using real URLs here. We are just using a list of numbers. So this can represent 10 different websites to scrape, right? Uh, Now, next, this scrapings can actually take up time. It can be sometimes 1 hour as well, depending on the website, as I said in the previous video. So yeah, now this driver function, what it does is basically it's kind of a main. Okay, we can call it main actually. That makes more sense. Now let's define main URLs. Okay, and fetch URL or scrape URL. So this will scrape our URL uh, for URL in URLs. And we are defining our scrape URL function as well. So URL, uh, this might take up some time. We don't know how much, but we will use some random function to define our fetch time for this URL. So fetch time is say random randint 1 to 5. So it might take up any number between 1 to 5 as this much of seconds. So time dot slip, we're just slipping for this time. We're not actually fetching something, but we can simulate the fetching using this random function and time dot slip, right? So you can think of it as we are fetching something and it's taking the time equal to fetch time, which is random here, anything between 1 to 5. Now at last we'll be printing something as fetched URL in time seconds, right? Okay, let's run it. Let's see how is it working. This is a very simple construct here. So fetched 0 in 2 seconds. Okay, we don't want to keep 0 here. So they're getting fetched, and it will end in like 10. I think the ninth one will be the last one, and after that this will stop. Yeah, exactly. Now in real case scenario, we might not want to do that. We want to run some infinite loop, and these URLs are going to be like in thousands, right? So this will be done in a infinite loop. Okay, let's decrease the time and run it. Fetch to 1 in 1 seconds. Yeah, it goes on like this. Cool. Now what we want is basically try to remember our last case, like last diagram. We want to make this URL calls asynchronous. Let's forget about this infinite loop for first. Okay. Now we want to call them asynchronously. So we, in some cases here, see this is taking 4 seconds, but we could have run the 1 seconds first, which are easier and like quicker to get, and then get the one that are delaying. But this is synchronous as we have a normal flow here. We haven't yet implemented async IO here, used the async IO here, but we will use that and see what is the difference, right? Again, we are not going for the infinite loop for now. We'll do it later part once we do this asynchronous first. So the first change that we need to make is async here, right? So this is asynchronous, right? Okay, we might not want to. Okay, it's not an issue. The thing is that once you use the async keyword here, it's no more a function definition. It's a definition of a variable called main. Now main is a coroutine, right? If you uh, run call main with a list, URLs is a list basically, it won't run. It would return a coroutine object, right? So coroutines are handled by event loop. So event loop is equal to async IO get event loop, right? So async IO has returned one event loop, right? Now once we have our event loop, we will so this was a function call in the last case, but it's no more because now it's a coroutine and will be taken care by the event loop. Okay, this is how you do it. Yeah, that's pretty much of it. Let's run it. Okay, now see, nothing is happening actually. Why? Because we have only scheduled this main URLs coroutine inside async IO event loop, but we haven't really run it. Okay, so we want to run it. We want to call some function that is event dot run forever, right? Except keyboard interrupt. So we can press Control C and stop everything using the event loop dot close, right? Let's run it now. Yes, it's working. And if I press a Control C here, it will be stop. Okay. Now let's try to have a closer look at how it is working here. So fetched 1 in 2 seconds, fetch 2 in 1 seconds. You can see this is not asynchronous yet. Okay, we are running this particular function, this main, asynchronously, but there is no asynchronous competent, like competent with main. It's single, right? We don't have many main functions or many main coroutines here. It's just the only one, and it's running just like a normal synchronous coroutine, synchronous function. What we want is that to run these ones as synchronous coroutines, right? We want the easier to, like the quicker s- scripts to return faster first, and then the delayed one, right? So for that, we need to we want to use a list comprehension here. So we have some function called, okay, there is a keyword called await. What await does is that whatever you write after this will be, it's a pointer would be returned to the event loop. That means this next part, whatever I'm writing here, will be taken care by the event loop, and the control will be passed to the next line, right? So here you are just saying, okay, I'm not going to handle this, whatever this is I've written here, it would be taken care by the event loop, this whole thing, right? Not just the list thing, whatever I've written after this. Now I would come to the next line. Okay, now what I'm going to do here is write some coroutines, that is scrape url for url in urls, right? Now we'll be having some error here. I'll show you. We need to wait a bit. 7 8 9, yeah. Now see, what is happening is basically, these are function calls, right? So what happens first, Python executes the inner one. That's why it was running through this list comprehension. Once it was evaluated, it gets returned to this async io.wait. Now async io.wait is expecting a list of coroutines, but we are returning what? So these are like by default Python functions. If you don't write something specific as return 0 or 1, it would be returning a none type object, right? So this is returning 10 none type objects as a list, and async io wait is not expecting none type. Okay, so that's why we don't have a coroutine. See, a coroutine is required, a coroutine or an awaitable is required, but we are passing a none type object, right? So that's why the error is. What we can do is that we can simply call async. Now this is a coroutine, this script url. Okay, it won't be run uh, here, but here it will be done here, right? Now see the difference. See, 4 was fetched first. Basically what happened here, 0 to 9 all were scheduled to the event loop. All of them are running asynchronously, but the ones that were like taking up less time are coming up first.